Hey there, in this video we're talking about file processing with loops and error handling in C++ programming. And this covers the second half of section 5.11 in the Gaddis textbook that introduces file handling for the first time. So we got started with basic file handling of simple flat text files in the prior video, but the examples that we saw last time were very simple. In each of those cases, we were only reading or writing maybe 3, maybe 4 pieces of information to or from the file, and it was fixed. It was a fixed number of things that we were dealing with. So of course the whole point to files is to be able to store a larger amount of data very efficiently and to be able to read it into our program even if there's hundreds of pieces of information or maybe even thousands. So in this video we're going to build out and show you how to handle that, and it's not very hard at all. But in this video, really, it's going to look more like file handling programs really ought to, what they need to look like. So let's get into that. Now, a couple details to begin with. First of all, and maybe I should have put this in the prior video actually, is there's the concept of the working directory. And directory is the same thing as a folder in operating systems. Kind of directory is the old word and folder is the new word, so to speak. So the working directory is a directory or a folder that's dynamically associated by the operating system with any program. Any program has a home. You might call this the home directory. So when a program is running, it has a particular place where it lives, and that's what we mean by the working directory. By default, this is the folder where your program is stored and being run from. Again, on Windows, that the program is your file with a .exe executable extension. That's really the program it's running. So wherever the exe file is, that's what we mean by the working directory. And why that's important for us today is that when you do file handling operations like opening or reading or writing, the operating system looks for those files in the same place. That's where the operating system expects to see the data files that you're trying to open. So if the data file that you're trying to open or create isn't there, then that's a logical error. There's going to be a file open error happening, and we're going to have to handle that here in this video today. So that's one of the things that can go wrong when you try to open a file, is if it's not there in the same place as the exe in the working directory. Okay, so the very easiest thing, and this is what I was doing all through the prior video, and I'll continue to do that, is wherever my executable is, I need my data files to be in the same place. I need to be really aware of the location in the operating system of where these things are, and the easiest thing of all for us is to have the executable in the same place as our data files. So you need to make this happen when you're practicing file handling initially. Couple other alternatives actually. Alternatively, if you didn't want to do that, you could provide the full path name to where your data file is. You could say my file is in c://myfiles/data.dat if that's where it is. Or there's actually another option is you could actually put it in what's called the path, the system path. But that's just totally overkill, so there's no need to do that. So much easier to just put your data file in the same folder with the exe. So at least for my beginning students, I know that this is a big road bump, as a matter of fact. So frequently I'll have students that aren't really aware of where they've put things, and the very first thing they'll say is, my program's not working, and my program's not reading the file. And I go, where did you put the data file? And they may go, what do you mean by that? And I know that's the problem. They didn't put the data file in the same place as the exe. So make sure you're doing that. That's the simplest thing to do. Otherwise, you try to open it up, it's not there, that's an error. Okay, we'll talk more about that in a minute or two. Now, here's a thing that you definitely want to do. Maybe you could have come up with this yourself in the last video. Is, you've got your program set up in a folder properly. You've got your exe, and you have one data file. Maybe you have more. You've got a second, a third, a fourth data file. So it's kind of obvious that you might want to give the user of your program the option of which of those data files to open up. And that's what we're making happen here. So you can do this. Right? That file.open function, the parameter that it takes, in our prior examples, we always had a string literal, a fixed literal name for a file. There's no reason that can't be a variable. Why not? Why not give it a string variable? So you can do that. The file name to open there can be a string variable specified by user input. That's perfectly fine. So what we can do here for a slightly more sophisticated program is we can prompt our user, which file would you like me to open up and use right now? Right? So prompt them, use a SYN statement to read in their response to this string variable, and then do your file open operation and pass that variable into the file open function, and therefore you're giving your user the choice about which of several files to make use of. That can work. That works great. Very simple. I mean, it's kind of obvious. You kind of want to do that. But, maybe our user gets confused. What if the user enters a file name that doesn't exist? So this file.open is trying to open a file that doesn't exist. I mean, that's something that's almost certainly going to happen at some point. So we're going to have to handle the case where the file is missing, or it's in the wrong folder, or the user mistyped it, or it got deleted by some other system or something like that. We definitely need to handle those possible error conditions. That's on the next slide. Okay, so testing for file open errors. All kinds of ways this could happen again, based on those prior slides. You didn't put the data file in the working directory. The user named the wrong file or mistyped it. So how do we handle that? You can test a file stream object to detect if an open operation failed. Basically, when you do your file.open operation, among the variables inside the file stream object, there's a Boolean keeping track of whether it's successfully connected to the hard drive. That Boolean is going to be true if it did open up, if it did find the file successfully. It's going to be false if it couldn't find it. So, and actually the name of your file stream object will return that Boolean. So the name of your file works like a Boolean, true or false, about whether it was opened up successfully. That's really convenient. So one thing that we'll commonly see is, let's say I have a file stream object called infile. It has to be of type IF stream for this to work. So you try to open up this infile. You write infile.open. You name test.txt. Maybe that file is in the working directory. Maybe it's not. I don't know right now. So your input validation, so to speak, you're validating whether that worked, is you write down an if statement and you write down not infile here. So if the infile failed to open, right, remember how this works, not infile turns that to true. You get into the body of this if statement here and you print out a good quality error message. You print out file open failure or something like that to the user to know that they couldn't actually find the file. And then presumably there's an else section here that is used if the file was open, and then you actually go and actually process it and do what you want. But that right there is how you check to see whether the file was successfully open. Now I guess there's another option here, right? So that's what I normally do because it's the shortest thing, is just treat the name of the file object as a Boolean, true or false. And so if it's false, throw up an error message here. There's a second option here. There's another object member function. In addition to open or close or stuff like that, there's a function called fail. So in place of this not infile, we could have written if infile.fail empty parentheses, and that would actually do the exact same thing. It's a little bit more typing, but some people find that to be more readable. So, arguably maybe we should be doing that. Either one you want to do for our course is perfectly fine, but we do for our upcoming programs and assignments, we definitely need to validate that the file was actually opened before you get data out of it. Okay, so that'll be good. Now, next thing, using loops to process files. Again, all the examples previously were just reading or writing maybe 3 things, and it was a fixed number of things. Those programs couldn't do any different than just read or write the 3 things, that's it. But to be useful, our files should have lots of data in them, should have dozens or hundreds or maybe thousands of pieces of data. So we don't want to have to repeatedly write down the input-output statements. Of course, we want to use loops to handle that automatically efficiently. And here's what that's going to look like. So the neat thing is that the stream extraction operator that we always used to use with SYN, but now we're using with files, returns a Boolean, true or false, about whether that particular attempt at reading one piece of data was successful or not. So you're going to try to read one piece of information out of your input file. And if that works, then this is true and you can check it. And if it works the next time, it's still true. You can check it. But if it fails because you've run out of information in the file, then this returns false. And that's how you can make a decision about what to do next. So what we're usually going to do is we're going to use that in the context of a while loop. You can test that inside a while loop to continue execution as long as values are read from the file. So here's a while controller here, and you can see here is our input statement trying to read one number out of your input file. So you get in here, it tries to read the next number and put it in this variable. If that works, it's true. And you go into the body of your while loop and you print it or you add it, or you do some kind of calculation. And you come back, right? And you try it again. Try to read in a piece of information number. If that works, this is true. You go back in the body and you do your process. Great. You come back here, and if it fails, if there's no more numbers in the file, this will be false, and that's what gets you out of the loop. So, and just a little bit more detail about that. So the way that this is actually working, and it's not something you'll ever see, but the way that this actually works is at the end of every file, there's a special marker called the end of file marker, or EOF for short, as we say. EOF for the end of file marker. It's a lot like the null terminator at the end of a string, a special byte at the end of your data to mark where it ends so C++ knows where to stop. So it's like a null terminator. It's basically a sentinel. It's a sentinel, a special value marking the end of some data. So if you think back to all the times we've talked about sentinel controlled data starting in chapter 5, is if you don't know how much stuff is in your data, you'll have to use a special marker at the end. And to control that, you'll have to use a while loop just like you see here. So using a while loop, hunting for the end of file marker via the extraction operator, and it works very similar to finding the end of a string or some user-controlled loop. Now, as a side question, hypothetically, if you knew, and you usually don't, but if you knew exactly how much data was in your file in advance, what type of loop could you use to handle that? What would that be? And of course, the answer would be, well, for that, you could use a for loop. If you know the number in advance, that's what a for loop is for. But with files, we want our programs to be flexible. You don't need to know how many things are in the file. You usually don't. So you're going to have to rely on that end of file sentinel, and you're going to have to control them with a while loop like this. And that's what it's going to look like all the time. All right, so here's a nice example. This is program 524 in the book, and this actually puts together everything we've been talking about so far in this video. This has a user-supplied file name. It has a number of files available for the user to open up. It validates that the file they asked for is actually one of the things that's there, and then it uses a loop to process and get all the data, even if you've got a very short data file or a longer data file. It can handle any one of those things. So a very nice example. So it starts off here, and it's declaring a file stream object of type ifstream for input coming in to your program, which is mostly what we've been focused on in this video, actually. Here is a string to receive the file name that's going to be specified by the user. Again, there's going to be several options for files here. So the user is going to tell us that. We're going to put it in this string. And then all the files in question, they all have numbers in them. They all have integers. So here is an integer called number to receive each individual value as it's being read in. So first of all, in this slide, and there's another slide yet to come, we're asking the user, please enter the file name. Which file do you want us to open up and print to the screen? Could be anything here. So here's a SYN statement where the user on the keyboard actually types in the name of the file that they want, and that gets saved in this string variable. Here on line 18, like we're saying, here is where we're opening the file that the user specified. So here's input file.open, not a string literal, that file name string variable, whatever the user asked for. Okay, now again, maybe that's there, maybe it's not. So the next thing we ought to do on the next slide is we ought to validate whether the file was successfully found and opened. So here's this. So this is actually kind of working in the reverse direction from what we had for an example in the lecture here. Remember, the name of your file object works like a Boolean, true or false, depending on whether it was successfully opened. So here, we're looking for the input file to be true. You've got if input file is true, then it was opened up, and then you can go into this block here from line 23 to 31 where we're actually going to use it. I'm going to come back to that in a second, but here we're clearly reading stuff, and then we're going to close it at the end. But if the input file value is false, which is what would happen if it can't find the indicated file, then you're going to jump down to the else part here, down to line 35, and you're going to get that error message. You're going to print out error opening the file. So the user knows why they're not getting any information back. But back up to the true part. So if the file was opened successfully, then you get here to line 25, and this here is that while loop controlling the data flow, because the file might be shorter or it might be longer. We don't know how much stuff is in there. So you get to line 25, and it tries to read the first piece of data from the input file, put it in number. And remember, that extractor operator, that also returns a Boolean true or false, depending on whether that works. So if there is a piece of information in the file that's going to be true, it's going to go into number, and then you get to line 27, and you print number to the screen. And then you're back on line 25, right? You try to read another piece of information in a number. If it's true, you're back on line 27, you print it out again. Go back to line 25. Now at some point, you hit the end of the file. There's no more information. You hit the EOF marker, the end of file marker. And then this fails, and this extractor counts as false. And that's how the while loop ends. And you drop down to line 31. And of course, here we are closing the file at the end. So you write input file.close. That closes the file, releases the lock, cleans stuff up for Windows. Other programs can use it. And then, of course, you're down on line 38 and the program's over. Okay, so let's try this out. I've got this program 524, and again, as usual, I've made a dedicated folder. I've taken the examples out of our code repository, put it here. Now, I've got the source code file, of course, the C++ source code file, but now there's a whole bunch of data files that the book provides us for testing purposes. So now there's a whole bunch of files running around. There's list of numbers.txt, there's numeric data.txt, there's random.txt, and I've put all of these things, again, in the same folder where my program's going to be. So let me compile this. And of course, compiling makes the executable file, pr524.exe. Now remember, that's the real program. So when you start running it, that is what you're running, and wherever that executable is, that's what we mean by the working directory. This folder right here, this is the working directory for this program, because that's where the executable is. So, so I need all my data files in that same folder with the executable. Otherwise, it's not going to be able to find them. So let's, let me take a look-see at what's in those data files, just so I'm familiar with them. There's a list of numbers. Okay, so that's got numbers 1 through 700. Okay, that's a good list of numbers. There's numeric data, which is shorter. Okay, there's less data in there, and then there's this random.txt, which is, oh my goodness. It goes on and on and on and on and on and on and on. How long is that? 200 lines? Oh my goodness, that's 200 numbers. 200 numbers there, right? And some are smaller, some are larger. That's a lot of data, obviously. But see, this program is going to be able to handle any one of those things. So I should test all of those. I'll test this 3 times. So the program asks the user for a file name. That's what's happening on lines 14, 15, and then on line 18, it opens up that particular file name. So maybe the user wants a list of numbers. List of numbers.txt. Of course, you got to put in the file extension here on Windows. That's very important. It's very important that you've got it set up to see the extension. Otherwise, this is not going to work. So hit enter. And yeah, there's the 100 through 700 that's in list of numbers. So it successfully reads all that stuff and prints it to the screen. Let's try something else. Now the user asks for numeric data.txt. Great, so we access all that stuff. There's not very much stuff there, only 3 things, 10 through 30, but that works. And let's see if this handles that enormous list of random numbers that's in random.txt. Great, no problem, no problem. So that is actually all 200 of those values sitting here, right? All that stuff is in there. And of course, our computer, again, is working so fast that it appears that it just instantaneous, all that stuff appears on our screen, but it is being read one at a time and then printed. Read one at a time and printed. And it runs very, very, very quickly like that. Super. You can see that when I ran that, it was saying that it took 6.9 seconds for that program to run, but most of that time was waiting for me to type in the file name. Once I get the file name in there, it was more or less instantaneous of getting the rest of the stuff. Well, now what else? I should also test the validation, right? What if the user types in, like maybe they think there's a file called numbers.txt. Okay, well then you get the error opening file message, right? And this program is handling that properly because you checked on whether it was open on line 21. In this particular case, that was false. So we jumped down to here, and that's where the error opening the file came from. Great. If I didn't have that, the program would just do literally nothing, and it would be unclear to the user whether it was working or not. What else? What if, a common mistake is to not put the file extension on it. So if I ask for just list of numbers, right, without the .txt, see, that's a different file name. List of numbers would be different from list of numbers.txt. So that would fail, and we should check for that. Again, that's why it's important to see the file extensions in the Windows operating system, because if you just write list of numbers, which is actually what Windows wants to show you, normally for non-programmers, that won't work. You've got to see the extension there. What if one of the files is deleted? So let's say numeric data gets deleted at some point. Now, obviously, trying to open numeric data.txt now, that's not going to work. It's not there anymore. I guess I can Control Z to bring it back. What if it was in a different location, right? We said it was very important that the file be in the working directory with the executable. So now I'm just going to move it over here. So that's a different location on the desktop. It's not in this directory anymore. So now, if I run this and I ask for numeric data.txt, okay, see, program can't find it there either because it's not in the working directory. This is where it would have to be. So that kind of emphasizes all the different ways that the file opening could fail. User could mistype it, user could forget the extension, could have deleted it, could be in a different location like it is right now. But if I do move this back, right, now it's in the working directory, and now this program can find it very easily. Let's try that one more time. Of course, that's where that's supposed to be. Okay, so that's what we definitely need, that validation here to handle all those different cases where it can't find the file. But let me look real closely. Of course, most of the work, once you've opened up the file, most of the work is being done by this while loop here. So let me just I don't need to go through the whole thing step by step. I'm going to put a breakpoint here, run this in the debugger once. Okay, and I'm just going to open up that numeric data, which is the short file. Okay, so the program's running, right? It has successfully opened up that particular data file because we didn't get the error message. So now it's waiting to run this while loop, and I'm going to put a watch on number. Okay, number's currently got random garbage in it, I think. But I'm going to run next line, and we'll pull out the first thing in numeric data. I'm just going to remind ourselves what's in there. Right, so the first time this runs, it's going to pull out the 10. See that right there? Put that in number. And of course, the extraction succeeded, so that was true. And that's why the while loop decided to send us into line 27. So now, of course, we're just going to print that 10 to the screen. And it shows up in the console over here. There it is. I need to get so much stuff here. I'm having trouble finding space there. So we're back on the while loop, and we're going to do that again. So you go to the input file, get the next thing out, and send it to number. And of course, that's going to be the 20. Great. So sitting in there, and of course, the extraction was true. We got into the body here. So now we're going to print that to the console. 20 shows up over there. You're back on line 25. You try to read another number. That's going to work. Now you've got the 30 in your number variable. You print that to the screen. Where are we going to go now after line 27? Of course, we're going to go back to line 25, right? Every time you do the body of a loop, you go back to the controller. So now it tries to do this again, tries to read another thing out of the input file, but there isn't another thing. There isn't any other thing. The only thing that's left there is the end of file marker, which is invisible and you never see it, but we know that it's there. So in this case, this is actually going to fail to read in anything to number. Number is going to stay at 30. That extractor is going to return false, and that's what gets you out of the while loop, and you're going to jump down to line 31, of course. Right? See, number didn't change. You did not successfully read anything out. The input file closes. That sends you down to the bottom of the program, and now we're done. Okay, so that's exactly what's happening in that while statement there on line 25. So take a close look at that. Make sure you understand how our while statements are set up, and that's what's permitting this program to handle 3 items like in this file, or 7 items, or 200 items over in random.txt, right? This program will very easily handle any amount of data, and once you tell it to use random.txt, it's so fast, it just looks like all the stuff's on the screen all at once. But it is doing it one step at a time like this, of course. Okay, other thing. Now, that was an interesting example there of reading any file in, really, based on user input, whether it's longer or shorter. But all we were doing with the incoming data was just printing it to the screen. I mean, that's not super interesting. So what I would really like to do is I'd like to store all of that data in memory in an array so I can process it in more interesting ways later on, like compute statistics, find the minimum, maximum, total, average, stuff like that. Of course you want to do that. So how do you save all of that information? Of course, you're going to use an array. But the problem is you don't know how much stuff is there. You don't know whether it's 3 things or 50 things or 100 things. So if you think back to chapter 7, where we talked about that, the solution to this is to use a partially filled array. So let's think about that again. Commonly, a data file will hold many values, and we don't know how many in advance. Of course, I mean, that's what it's like. Or the data file had 20 items today, and then tomorrow more data was added to it, and now it's got 25. So recall from chapter 7 that one solution for this is to use a partially filled array, and we stepped through that very carefully in a video for chapter 7. And as a reminder, what we're going to do is we're going to declare a very large array to start, something that's clearly more than you'll ever need. So just declare a really large array. And then as stuff gets read in with our while loop, like we always do, use a counter variable to keep track of how many items have been stored, just like we did before. And then when you do have all that data all stored in your partially filled array, then that counter becomes the effective size for later processing, for your for loops that come later on when you're finding the total or the minimum or the maximum or whatever you're doing. Okay, so very, very similar, and we totally need this technique precisely because we don't know how much stuff is in a data file most of the time. All right, let's take a look at this. So here's program 714. So this example, most of our videos here on file handling are coming from chapter 5. That's where introductory file handling actually sits in the Gaddis textbook. But of course, we didn't see arrays until chapter 7. So this example here, 714, couldn't exist until chapter 7 when we had arrays to store all the data in memory. So here we go. So partially filled arrays are what we're going to need. So again, you make a really big array. We're going to make an array size 100. And none of our data files are that big, but just make it really big. So make a constant integer called array size, set it to 100. Here on line 9, we're declaring an integer array called numbers of size 100 to store all the data as it comes in. Of course, again, we need this variable to keep track of how many valid pieces of data are in the array. So it's being called count here, initialized to 0, because of course nothing's been read in when the program starts. Most of the partially filled array is going to be all random garbage. So the count is keeping track of how many things are actually good data and not random garbage. Now, here is on line 11 where we're declaring the ifstream object. We're calling it input file, where we're reading information from. And on line 13, now this program here does have a fixed name. Again, we could have made this user-specified file name to work with anything, but at least for an initial example, this program only works with a file called numbers.txt. So writing down input file.open numbers.txt. That is the one file that this particular example works with. Now, most of the work is being done on line 18. And that's why there's kind of a big comment here about this. So really take a close look at line 18. You got your while loop to read in information from a file when you don't know how much stuff is really there yet. And most of the work's being done on the end of this line. There's input file, extractor into the array element numbers sub count. So of course, the first time that runs, the first piece of information will be sent to numbers sub 0. Of course, that's the first thing in an array. And then once that happens, you'll go to line 19 and count gets incremented up to 1 to keep track of the fact that you've currently read one thing in. And you'll be back on line 18 and you'll do input file extractor into numbers sub 1 because count will now be 1. That's the next thing in the array. Okay, and presumably that works. The extractor value is true. You go to line 18, count now gets incremented to 2. And it goes on and over again. And of course, at some point you hit the end of file marker. This returns false. You don't read anything in. The while loop is over. Now, the other thing you see here they're being careful about that we've been careful about before is, of course, in addition to that, in addition to successful read operations, you need to make sure your count doesn't go over the array size. There's only 100 things in this array. And if you go over that count, if you go over array size, remember what that would be? It's called a buffer overflow. And at that point, you're overwriting random parts of memory, and anything can possibly happen, including crashing your program, crashing other programs, getting incorrect results, or for me, I've fried a hard drive that way in the past. So I'm glad that they're being careful to make sure count does not go up to 100 or 101 or 102 or something like that. That would be very bad. So that's smart. That's why they're doing that. Now, once that loop gets over, you've actually read all the information. It's being stored at the start of your array. Then, of course, you close the file, and then you can do some kind of processing. Now, here in this example, they're just printing all that stuff out to the screen. So here is your standard for loop. At this point, you know how many things were read because it's sitting in that count variable. This for loop here, again, starting at 0, it's not going less than array size. It's going less than this count of the valid data. And every step along the way, you're printing out numbers sub 0, and then numbers sub 1 and numbers sub 2, however many things you've read in. All right, let's try this. So I've got program 714. I put that in a dedicated folder. I've also got the numbers.txt data file that comes with it out of the repository. Both of those things are sitting in the chapter 7 lecture code folder. So let's see if this works. I'm going to compile this. Of course, there's the executable file. That's the real program there. And you know, I'm going to take a look at what's inside numbers.txt before I actually run the program. Okay, great. So what is it, about 10 numbers or so? I guess that's 12 numbers. Starts with 47, ends with 62, some larger than smaller. Kind of looks like test grade scores to me. Good enough. So we run this, and it works. Okay, so it reads in every single one of those things, starting with 47 to 62. In this case, again, where it's not just printing them to the screen, it's storing them in an array. So it is holding all of these numbers in memory at the same time, and it's just printing them in this particular example, but we could have done something like compute the statistics, find the total. We could have done once it's in the array. Let's run through this, maybe just a couple steps to see the action on line 18 here. So I'll put the breakpoint right here. Right, the file's been opened at this point. Nothing's been printed to the screen. And I'm going to keep a watch on the numbers array. And also this count variable. Kind of the important things here. And I guess also the number, right? Number that actually gets the input. Well, that's the array, of course. It's hanging off the end of my screen there. Okay, so as a program starts up, count's been initialized to 0 because line 10 happened. And the numbers array, it's a really big array. It's 100 things. Bunch of random garbage there. Of course, it's uninitialized. Some larger, some smaller. So let's see here. I'll just take an eye on what's in the file. Just as a little reminder over there. Right. So you get to this line 18. And let me see. Count needs to be less than array size. Of course, 0 is less than 100. That's fine. So we're going to run our extractor. We're going to get something out of the input file, that 47, I guess, and send it into numbers sub 0, which is the first thing in the array. See that happen. Great. So it took the 47. You can see right there what got put in numbers sub 0 at the start of the array. Awesome. So since that worked, the extractor returned true. Now count gets incremented to 1, and we'll go back to line 18. Right, so count is 1. Recording correctly that we have read one thing into the array. And that happens again, right? Goes and gets the next number, which is the 89, and puts that in the second location of the array, in numbers sub 1. And then count gets incremented. Now there's 2 things in there, right? Read another thing out, namely the 65, that gets put in the array here, and count becomes 3, and you go on and on like that, of course. So don't forget that with this partially filled array, it's still mostly random garbage. The count is 3, saying it's just the first 1, 2, 3 locations that have legitimate data from the actual file. So that's what that is there for. And of course, I'm going to run this full speed here. Just hit continue. So it goes through that loop very, very fast, right? And at this point, it's read everything out of the file. Okay. Now, so the whole loop ran, and we're down in the output part, and now you can see that the first 12 things, right? The count is 12, and the first 12 things are legitimately all the data out of the file, but the other stuff, the other 88 elements, are still all random garbage. So, hypothetically, you could say you're kind of wasting that space, but we didn't know to begin with how many things were in the file, so we had to use a partially filled array like this. Now that you know that, now you can do your processing with a for loop using that count as the number of things. So now it's going to go through, and this for loop here is going to happen 12 times, and out comes the first number, and the second, and the third, and all those numbers one after the other. Of course, if we're running this full speed, it would just look instantaneous, but it is happening, one single thing being pulled out of the array at a time and put on the console. Nice. All right, so I think that's a pretty good introduction to file handling. Again, there's larger story up in chapter 12 that we cover in second semester programming, advanced file operations, including more stuff with text files, the other side of the story, binary files, where you don't actually have ASCII readable text. It's just binary numbers in the file. Writing larger blocks of data efficiently, jumping around the file, having it both open for input and output at the same time, all kinds of stuff up in chapter 12. But I think it's good to have in your starting toolkit just dealing with basic text files. For my work, this is generally all I need. I do a lot of programming, and all my programs have to have some kind of file handling component to get the data in. And frankly, everything you've just seen in these 2 videos is pretty much all I ever use. It does the job. So I'm personally really happy to have this in my toolkit. So I would recommend for my students to read section 5.11. Again, that's the last section in chapter 5, where this information on basic file handling is. We skipped over that earlier in the semester, but I'm glad we got the chance to go back and fill that in. And then my students will have a programming challenge with file handling. It comes out of chapter 7, and they do have to read information from an unknown file, store it in an array, do some kind of processing with like statistical processing, make sure the program's modular with separate functions, of course. And this right here is the last programming challenge that I ask my students to do in first semester starter C++. So I like this challenge a lot, actually. It gets to practice everything we've been talking about: data coming in, data going out, storing an array, a partially filled array, getting the name of the file from the user, validate that the file's open, all that stuff, modular program, bunch of separate functions to do array processing once it's in the system. So that's kind of a really good capstone for first semester programming, I think. Recommend to my students get started with that early, right? It is certainly the most challenging thing we do in this first semester, so get started early and make sure you've got a couple days to iron out the problems that you're probably going to have. But the important thing is that you are refreshing and reminding yourself and practicing all this basic stuff in first semester. So that's important. And then my students would get together with me for this lab, something like this, reading grades from a file into an array. So just practicing what we're talking about. And what this asks us to do is in the lab 7 folder, there is a data file called gradfile.txt, which holds a bunch of grades, holds a bunch of student grades. And there's no program. There's no code that comes with it. It's just a data file. So in this lab, we have to write the entire program from scratch, from start to finish. And we're going to have to use all these techniques we were talking about in this video to read in all of those grade scores, store them in a partially filled array, and then what we're being asked to do is find and report on the lowest score. Right? Kind of keep an eye on who's in trouble, I guess. So we're going to use separate functions for input and processing. And if you're one of my students, you might want to go back and remember, study up on how do you find the lowest thing in an array, the minimum of an array. And we did talk about that in chapter 7, that algorithm there. So you might want to study up and refresh yourself on that because we're going to have to do that in this lab. And that's a pretty good example of the kind of thing you want to do with files. Okay, so probably the next thing we'll do in the next video is we'll come and, this partially filled array business, we need that. It's a little awkward, honestly. It's a little weird that we're making this really big array and we're not using most of it. We're only using the first couple of elements. That's what we've had to do so far with basic arrays. Maybe there are better ways. Maybe there are better ways of doing that in C++ programming. So in the next video, we're going to talk about one of those ways. There is a more advanced object called the Standard Template Library Vectors, the STL vectors. And that actually is a lot more efficient to handle various amounts of data because unlike an array, that can actually grow. If you have more data, it can just grow automatically and handle the growing amounts of data. So if we did use an STL vector, that would actually make this lab right here a lot easier, frankly, because we could skip out on the partially filled array and the count and the stuff that's mostly not being used. But it's good practice because you know what? STL vectors are actually built on arrays. They actually secretly have arrays inside them, frankly. So good to do this lab here that's in front of us and really understand the most basic way of handling lots of data, which is arrays in any programming language. But next time, we should look at these vectors and see how the fancy way of doing that is. So hopefully that sounds interesting and useful, and I'll look forward to seeing you for that.